Good evening. So I'm going to do a little bit of a tutorial on the Chapter 3 math practice problems, those math practice problems. They're basically percent change and percent difference, and a couple of things that you really want to pay attention to is that percent change really relates to when time passes and you have two different values and you have a difference in those two values, and then you look at the original value and you see like growth or decline or something like that. And that is you're referring to the same measure in two different points in time. And then to calculate percent difference, we're really looking at two values at the same moment, but then looking at the difference between those two values. So we use in the denominator on percent difference. One of the things I want to point out is that this is the mean, which is average, and that's the average between the two values is what you use instead of the original value. So that's a major difference. It's like what's being measured, kind of like the same value at two different points in time, and then this one is just two different values. It may be the same thing, but they're coming from two different sources that way. All right, let's dive in. So on the first problem, I'm going to do my steps that I introduced you to. And so that we can you can kind of see those. And then I do want to tell you, I found the worksheets that have those 5 steps. So if that's something that you're like, I really like that structure, I can definitely make sure that you get it. We always start with what we know, not the unknowns, even though I messed up the first time. So I'm going to do it in pen so you can see it. I would not recommend doing any math in pen yourself, but I'm looking at my answers here and I'm going to break this down. So in the city of Blacksburg, the average consumption of electricity per household is 900 kilowatt hours per month. And so I'm going to make sure that I get the things that I'm given written down. Kilowatt hours. We'll go over what that means later. Has to do with, kilowatts. So we're looking at electricity. And then in the town of Springfield, the average consumption is 1,020 kilowatt hours per month. So you've got the same unit, and you're looking at a rate here because it's per time. And so the question asks me to calculate the percent difference between the two average consumptions in the two towns. So I'm going to be using this percent difference piece, which means I have to figure the mean for the denominator in that one, and then take the difference between the two values. And one thing that this doesn't mention here is it doesn't really matter which one is more or less, because the percent difference is an absolute value. So then number 2, I am looking for percent difference. So I figure like what do I need to calculate? My formula for percent difference is, forgot my little percentage. Percent difference equals value 1 minus value 2. That's an absolute value piece. And then I take the average here. So value 1 plus value 2 divided by, first that, and then divide that value by 2. Multiply that whole thing by 100, and that's going to give you the percentage. So my setup for this particular problem, consistency problems there. Once I circled that one, I couldn't go back. All right, so I'm going to plug this in. I've got 1,020 kilowatt hours per month. I'm always going to include my units. And I don't care how annoying it is. It's not that much more work, and it's a good practice for you. And then just take the average of that. I'm gonna skip the step of writing out the computation for the average, and I calculated this kind of on the side. So this plus that divided by 2 equals 960 kilowatt hours per month. All of those units are going to cancel out. going to multiply this by 100, and I should have 12.5% difference. There is my answer. Then in the next problem, number 2, you're asked about about percent change, but given this problem, a prolonged heat spell in the town of Blacksburg causes an increase in the use of air conditioners during hot summer months. The average consumption of electricity rises to 980 kilowatt hours per month. So now we have to go back. Like Blacksburg was 900 kilowatt hours per month. So this is where I look at my nodes. So Blacksburg 1, it was 900 kilowatt hours per month. But then the second value, the second rate, it rises to 980 kilowatt hours per month of electricity usage. And then I'm asked about percent change, delta for change. And then my formula for percent change is the value 2 minus value 1 all over my value 1, my original value to begin with, multiplied by 100, and that's going to give me my percent change. So number 4, let me plug all of this in. So I start with, in order to get percent change, I'm going to start with my second value, and then this one will tell me, like, if there's a negative value, then it is actually going to matter. In this case, there was an increase, so it's going to make it a little bit easier mathematically to subtract the smaller number from the larger number. But sometimes it's not like that. Sometimes you're going to get a subtraction of a larger number from a smaller number, and that's going to be, showing that there was a decrease in the value. 900 kilowatt hours per month, all over the original value, which was the 900 kilowatt hours per month. Multiply that by 100. So the difference is 80 kilowatt hours per month, but as I told you before, the units all cancel out. So you've got 80 divided by 900, multiply that value, multiply that value by 100. And so you should end up with an 8.89% or 8.9%, 8.9% growth or increase in electricity consumption. All right. And that's how you would use those two formulas. I'll just make sure you guys have the answers so that you can check your answers on the back side of that worksheet. So I'm flipping really quickly through the pages to find those answers so that I can give them to you. And gotta get on the right page. Okay, so on the back side, this one you're looking at, you should end up with a 160% difference. And that you might end up, getting a negative number, but that doesn't matter. It's just 160% different from the average of the two values. And then this one is 800% increase. So you can check your answers there. Number 4, the first one, the percent difference is 157% difference. And then the second one is a 18% loss. So you could say negative 18% or you could say an 18% loss.